Okay, are you ready to dive in? Because today we're going deep on the double slit experiment.
A classic.
It really is. It's one of those things in quantum mechanics that just throws everyone for a loop, and we've got some great sources for this deep dive. Really going to try to get to the bottom of it.
Yeah, Feynman, Bohr, all the big names.
They all have something to say about this, and it's kind of amazing how even they don't totally agree on what's going on.
Exactly. It's still a mystery.
So let's start with the basics. We're talking about shining a beam of light at a wall, but this wall, it's got two tiny slits close together.
Right, like a little barrier with two tiny openings.
And naturally, you'd think, okay, we're going to see two bright spots on the back wall where the light shines through.
Makes sense. That's what we see in our everyday world.
Right, totally normal. But here's where it gets strange, because instead of those two neat spots, what we actually get is this whole pattern of light and dark bands.
An interference pattern.
Exactly. And that's what's so weird, because that kind of pattern, it usually only happens with waves, like ripples in a pond, not with individual particles.
It's like each little photon of light is somehow going through both slits at the same time and then interfering with itself to create that pattern.
Okay, so the light is acting like a wave, but it's also made of particles.
It's like it can't decide what it wants to be.
And it gets weirder because our source, doubleslitexperiment.pdf, describes how if you actually try to measure which slit each photon goes through, like if you try to pin it down.
Which you'd think would make things clearer, right?
Right. But it's like the universe is saying, nope, not going to tell you. The interference pattern, gone. Just like that. You're left with those two distinct spots, almost like the act of observing it forced the light to pick a side. No more wave-like behavior.
It's as if by watching it, we somehow force it to choose, to collapse those possibilities into a single outcome.
Yeah, it's like we're messing with reality itself just by looking at it. And this isn't just some theoretical thing either. This whole wave-particle duality, it's the foundation for a lot of modern technology.
Well, absolutely. Lasers, transistors, all of that.
So we've established the quantum world plays by a very different set of rules.
Right. It definitely doesn't follow our everyday intuition.
But then the question becomes, how do we even begin to interpret those rules? What's really going on here?
Well, that's where the real debate comes in.
Yeah. Because there are a lot of different interpretations of what the double slit experiment actually means.
And these interpretations, they're not just about the experiment itself. They kind of point to different ways of understanding reality itself.
And they get really, really wild. So where do we even begin? There are so many different interpretations of this experiment.
Well, I guess the best place to start is with probably the most famous one.
Copenhagen interpretation, right?
Yeah, it's like the poster child of quantum mechanics. Everyone's heard of it.
Okay, so for those of us who haven't dedicated our lives to theoretical physics, break it down.
So the Copenhagen interpretation, it basically says that before we measure which slit the photon goes through, it's not really going through one or the other. It's like it's in this weird state of going through both slits simultaneously.
Okay, how is that even possible?
Well, they call it superposition. It's like the photon exists as a wave function, which is basically like a big cloud of possibilities or potentialities.
Yeah.
And it's only when we try to observe it, to actually see where it is, that wave function collapses into a single outcome, like it's forced to choose.
So it's our observation, the very act of looking at it, that forces the universe to decide.
That's the gist of it, yeah. And it raises all sorts of crazy questions about the role of the observer.
Which is where Schrödinger's cat comes in, right?
Exactly. That thought experiment really throws a wrench into things.
Because if observing a photon can make it choose its reality, what's stopping larger objects from doing the same thing?
Right. Where do we draw the line? And what does it even mean to observe something? Does it have to be a conscious observer?
Yeah, our source, Schrödinger's cat.pdf, really dives into those questions.
It's a whole other rabbit hole. But it gets you thinking, right? If a photon can be in multiple states at once, what about that cat in the box?
I mean, it's a pretty disturbing thought experiment when you really think about it.
Definitely highlights the weirdness of trying to apply quantum rules to our everyday world.
So the Copenhagen interpretation, it gives us this idea of observation shaking reality, which is wild enough on its own, but I'm guessing not everyone agrees with this interpretation, Rail.
Well, there are definitely some, let's say, alternative viewpoints.
What else could be going on here?
Well, one of the most talked about alternatives is the many worlds interpretation.
Okay, I've heard of this one. This is where things start to sound like a science fiction movie, right? Parallel universes and all that.
Yeah, that's the one. And it gets pretty wild.
So before we go splitting off into different realities, lay it on me.
Okay, so instead of saying the wave function collapses when we observe it, the many worlds interpretation says that every single possibility, every possible outcome of a quantum event, it actually happens.
It happens, but like where?
Well, in a different universe, it's like every time a quantum measurement is made, every time there's a possibility for something to go one way or another, the universe splits, creating a separate timeline for each outcome.
So there's a universe where I decided to have pizza for dinner last night instead of tacos, and another one where I'm a famous astronaut.
Potentially, yeah. It's like
Wow.
every possible version of you exists somewhere out there in the multiverse.
That's a lot to process. But if there are infinite versions of me out there, living out every possible choice, does that mean this version of me doesn't really matter?
Well, that's getting into some pretty deep philosophical territory. And the truth is, we don't know for sure if any of this is true.
I guess it's all just speculation at this point.
In a way, yes. But it's informed speculation, It's based on what we're seeing in these experiments, in the math and the way the universe behaves at this fundamental level.
So we've got Copenhagen, we've got many worlds. Anything else? Or are those the two main contenders?
Well, they're definitely two of the biggest players. But there are other interpretations out there. There are a few others, yeah. Not quite as popular, but still interesting to think about.
Yeah.
Like, there's this one called the de Broglie-Bohm theory or pilot wave theory.
Okay, that one sounds interesting. What's the deal with that one?
So this one, it's kind of trying to bring back a little bit of order to the quantum world. Instead of saying particles are in all these places at once until you look at them, pilot wave theory says they always have a definite position.
Okay, so what's the catch?
Well, they're guided by this, invisible pilot wave, which is influenced by both slits.
So it's like the particles following this set of directions that we can't even see.
Yeah, exactly. And because this pilot wave, it's not something we can directly observe. It's this hidden influence that determines how things behave. It's a pretty out there idea.
It is. But you said there are even more interpretations?
Oh, yeah, there are a bunch. Like the relational interpretation. That one's a real head scratcher.
What's that one all about?
It's kind of similar to Copenhagen in some ways, but it takes a different angle.
How so?
Well, it's not so much about a conscious observer causing this big collapse of possibilities. It's more about how different systems, like the observer and the thing being observed, how they kind of interact and influence each other, each with their own, perspective.
So kind of like how two people can see the same event in totally different ways depending on their own experiences?
Exactly. It's like each observation creates a unique relationship between the observer and the observed. And that relationship, that's what defines their shared reality.
Wow, so we've got collapsing wave functions, parallel universes, invisible pilot waves, and reality as a relationship, and I'm sure I'm missing a few. It's almost like the more we learn about this experiment, the less we actually understand.
That's quantum mechanics for you. It's definitely not for the faint of heart. But even with all these different interpretations, the double-slit experiment, it keeps revealing these incredible things about the universe.
It really makes you think, if something as simple as shining light through two slits can lead to all these mind-blowing possibilities, what other mysteries are still out there waiting for us to uncover them?
It's kind of humbling when you really think about it.
Absolutely. Well, I think we've officially reached mind-blown status for today, but hey, that's what these deep dives are all about, right? Getting you thinking, questioning, maybe even feeling a little bit of that existential wonder.
It's good to be curious.
It really is. And on that note, we'll leave you with this. If even the most brilliant minds in physics are still grappling with the implications of the double-slit experiment, imagine what other wonders the universe might hold, just waiting for us to unlock them. Thanks for joining us for this deep dive, and as always, keep exploring.